In this video, we are going to discuss about fusion versus fission, which will power our future. Hey there, science enthusiasts! You absolutely need to hear this if you're a science fan, especially if you're curious about the future of energy. We're talking about the next generation of power, the kind that could reshape our world. Fusion and fission are battling for the spotlight, two titans of atomic energy, each with its own strengths and weaknesses. It's a race to power our future, so let's dive in and see who comes out on top. Which one will ultimately win the energy race? Let's start with fission, the process that powers most of today's nuclear reactors. At its core, fission involves splitting a heavy atomic nucleus, like uranium-235, into two smaller nuclei. When a neutron hits the nucleus, it causes the atom to split, releasing more neutrons and a burst of energy. These neutrons can then trigger more fission events, creating a chain reaction. That's our current workhorse, splitting heavy atoms like uranium, a process that's been refined over decades. To keep this reaction under control, nuclear reactors use control rods made of materials that absorb excess neutrons, preventing the reaction from running wild. Fission is used not just in power plants, but also in submarines and aircraft carriers, providing reliable energy for years without refueling. This splitting action releases tremendous energy. It's a controlled chain reaction, carefully managed to provide a steady stream of power. It's reliable and already powers nuclear plants worldwide, providing a significant portion of our global electricity needs. But fission has its downsides. It produces radioactive waste that must be carefully stored for thousands of years, and accidents, though rare, can have serious consequences. Modern reactors are designed with multiple safety systems, including containment structures and emergency shutdown protocols to minimize risks, but it creates radioactive waste and carries the risk of meltdowns, posing significant environmental and safety challenges. These are issues we must address. Now, meet fusion, the energy source of the future. Fusion is the process that powers the sun and stars. It works by forcing two light atomic nuclei, like hydrogen, together to form a heavier nucleus, releasing enormous energy. It's the very same process that powers the sun, an almost limitless source of energy, burning far away in space. For fusion to happen, atomic nuclei must overcome their natural repulsion. This requires temperatures of millions of degrees and immense pressure, conditions found in the core of stars. Fusion smashes light atoms together. Think hydrogen, the most abundant element in the universe. On Earth, scientists use powerful magnetic fields to confine super-hot plasma inside devices called tokamaks, trying to replicate the conditions of the sun. The ITER project in France is the world's largest fusion experiment, aiming to demonstrate that fusion power is possible on a large scale. This unleashes massive energy with almost no dangerous waste, offering the promise of clean, sustainable power. It's the holy grail of energy production. Fusion produces only minimal radioactive waste, and there's no risk of a runaway reaction. The fuel, hydrogen isotopes, is abundant and widely available. The catch? We haven't cracked the code to make it practical on Earth yet. It requires extreme temperatures and pressures, a monumental engineering challenge. Researchers are making progress, but sustaining fusion reactions for long periods and extracting usable energy remain major hurdles. So, which wins? Which technology holds the key to our energy future? Fission is proven and available now, but comes with waste and safety concerns. Fusion promises cleaner, safer, and nearly limitless energy, but is still in development. Fission is here, providing power right now. But fusion could change everything once it's ready, offering a cleaner, safer, and virtually limitless energy source. The potential is truly game-changing. The clean energy revolution might just be a fusion breakthrough away, ushering in an era of unprecedented energy abundance. If you liked this exploration of energy's future, tap that like and hit subscribe. Stay tuned for more deep dives into the world of science and technology so you don't miss what's next. If you liked it, tap that like and hit subscribe so you don't miss what's next.